Okay, so now we're going to talk about composition of compounds. So, first thing we're going to talk about is the law of definite composition. And this law says a compound will always contain two or more elements chemically combined in a definite proportion by mass. So, an example of this is water. Water consists of the same two elements, hydrogen and oxygen, and the percent of mass by mass of hydrogen in water is 11.2%, and the rest is oxygen, of course, which is 88.8%. So, as stated here, water will always have these percentages for the different elements. If the percentages were different, then this substance would simply not be water. And it doesn't matter where the water comes from. It doesn't matter if the water comes from outer space, or if it comes from a river, or if it comes from your tap. The water, when you break down the percentages of oxygen and hydrogen, will always have 88.8% oxygen and the rest is hydrogen. Now, compare this to hydrogen peroxide, which contains the same two elements, hydrogen and oxygen. But this time, the percentage of hydrogen is 5.9%, and the percentage of oxygen is 94.1%, right? Now, in the case of hydrogen peroxide, these are the percentages. They're fixed, they do not change, right? And if these percentages were different, then this particular substance would not be hydrogen peroxide. Okay, so the next law we want to talk about is the law of multiple proportions. And this law says atoms of two or more elements may combine in different ratios to produce more than one compound. That's the law of multiple proportions. Now, as stated here, this particular law may not be in your text, but I regard it as important, so you need to be familiar with this law. So, to illustrate this law, let's look at comparing hydrogen peroxide to water. Now, let's say we weigh a certain amount of these compounds each, such that the mass of hydrogen in each case is 1.0 grams. Now, if you do that, then it turns out that the mass of oxygen would be 8.0 grams, and the mass and that's in water, and the mass of oxygen in hydrogen peroxide is going to be 16.0 grams. So we can see here clearly that when the mass of the hydrogen is fixed, the mass of the oxygen between the two compounds would be of a 2-to-1 ratio. All right, the mass of oxygen in hydrogen peroxide to the mass of oxygen in water would be 2-to-1 ratio. That ratio would be maintained between those two compounds. All right, so that's basically a demonstration of this particular law. So as stated here, hydrogen peroxide has twice as much oxygen by mass as does water for the same mass of hydrogen. And that is reflected in the fact that the subscript in the formula for water is 1 in the case of oxygen, and for oxygen and hydrogen peroxide, the subscript is 2, again reflecting the 2-to-1 ratio between these two elements, or these two compounds, especially since the hydrogens are fixed at 2 in terms of their subscript in each case. Okay, these are just some other examples of compounds which contain the same two elements, different compounds containing the same two elements, such as copper 1 chloride and copper 2 chloride. These are their percentages. They're different, even though they're made up of the same two elements. Methane and octane, methyl alcohol, ethyl alcohol, and glucose. They all contain the same elements, but their percentages will be different. So therefore, it is not just that the fact that they have particular elements that make up the substance, but the proportions of the different elements which makes the substance more unique. Okay, so the next thing we're going to talk about are the subatomic particles, and this comes about as a result of research that was done by different scientists. They found out that the atom is very small. Of course, Dalton was the first person that came up with his particular theory, and then of course work was done to discover more properties of the atoms, and that's what we're going to discuss today. So, as stated here, an atom is a very small particle. And just to give you an idea as to how small this particle is, if you take this dot that you see on your screen, right? Let's say that that dot has a diameter of 1 millimeter. Then it would take 10 million hydrogen atoms to form a line across that dot. So that gives you an idea as to how small the hydrogen atom is, all right? Now, even though we know about the atom being very small, and that's a fundamental particle for elements, that atom can be broken down into even smaller particles that are more fundamental, and these are called subatomic particles. And the first subatomic particle that was discovered was the electron, and it was discovered by this guy, Sir William Crookes, who invented a tube, which is basically an evacuated tube, which I'm going to show you in the next slide, which produces, when you apply what is called a potential difference across two electrodes in the tube, it produces an emission known as cathode rays. So this is what it looks like here. This is the version of Crookes tube, and it consists of a tube which is evacuated, and basically you have two electrodes, one electrode connected here, another electrode connected here, and you basically connect these to an external energy source, electrical energy source, and when you flip the switch, this is what happens. You see a stream of particles that emanates from this electrode, which is known as the cathode, towards the anode, but they're energetic enough to fly past it, and when it hits the wall of the glass fluoresces or lights up, all right? So when this was discovered, not much was known about the nature of this stream of particles, and people did some different experiments, one of them being Sir Joseph Thomson, and based on his experimental activities, he discovered a couple of things about these subatomic particles, which were subsequently, by the way, called electrons. He discovered that these particles, they travel in straight lines, they're negative in charge, and this is very important. These particles will be deflected by electrical and magnetic fields, right? They produce sharp shadows, and they're capable of moving a small paddle wheel, right? So this unit of charge, this fundamental particle, as I said before, is called the electron. And then another guy, a German this time, by the name of Eugen Goldstein, a German physicist, he discovered very shortly after the protons. And Thomson, he looked at this particular particle, and he determined their characteristics. And he also showed that atoms contain both positive and negative charges, right? And this is what led to the destruction of at least one aspect of the Dalton model, because remember Dalton said that the atoms were indivisible. Well, based on the accumulation of all these different types of evidence, we now know that that is not the case. We know that the atom is actually made up of these fundamental particles, the protons and the neutrons. And then back in 1932, right, which was about 50 years after the discovery of the proton, this guy by the name of James Chadwick, he discovered the neutron. The neutron took some time to be discovered because it was determined that the neutron has no charge. So before then, they did not have the means and the technology to discover the neutron. James Chadwick discovered it, and now we know that the neutron is also another fundamental particle that can be located in the atom. And upon further investigation, it was found that the actual mass of the neutron is just slightly greater than the mass of the proton. Okay, so we're going to stop here, and then we're going to start with a discussion of the introduction to the periodic table.